Hello YouTube, my name's Andrew, and in today's video I wanted to talk about math in Yu-Gi-Oh! Using statistics and probability to build an accurate deck. If you guys like this kind of content, really appreciate a subscription to the channel, and let's jump right into the content. So what is the correct amount of hand traps so that way you always see one in your opening hand? What is the correct amount of starters so that way you're statistically likely to open one? These are questions we aim to answer using math. For these calculations, I'm going to be using a hypergeometric calculator, which I'll link in the description. So for this deck, we have 10 hand traps in a 40 card deck. The calculation would look like this. We can see that there's a population size of 40. We have 10 successes being the 10 hand traps with the 5 card hand that we open with, and the success equals 1. So if we only were opening one hand trap, there'd be a 41% chance, but there's only a 21% chance that we draw no hand traps at all. I'm going to adjust this deck, cutting a few cards here, and we're just going to add even more hand traps. Let's just pick one here. So now we have 13 hand traps in a 40 card deck. And so I'll pull up my calculator for this. Let's see here. So we're going to go ahead and increase the sample size to 13. We can see that our numbers go up to 87% chance of drawing at least one hand trap in our opening hand. That looks pretty good. But since I'm very greedy, I'm going to continue cutting cards. I'm going to go all the way up to 15 hand traps in a 40 card deck. And let's just do the math here. So if I was playing 15 hand traps in a 40 card deck, you can see that I now have a 92% chance of opening at least one hand trap in my opening hand, and that is sufficient. So now we're going to take a look at starters. The Zodiac deck is very unique, kind of like Prank Kids, where you only need any Zodiac to start your combos. So we do see that this build is playing 10 copies of Zodiacs plus 3 Tenkies, giving us 13 starters. Of course, Pot of Desires could also become a starter, but we're not considering that in our calculations. If you did want to roughly estimate what the Pot of Desires would do for you, you can simply calculate with a 37 card deck, since those would basically be null and void, but it won't be a perfect calculation. So to draw one starter is an 87% chance with 13 copies in our 40 card deck, meaning that this deck will most likely play every single game. You can see that using the statistics on this deck gave us a good idea of like what kind of hands we're going to draw. One other test that I want to perform is what would happen if we simply add 3 more hand traps to this deck. Would the statistics go up and down favorably for drawing a hand trap? So I'll just throw in another hand trap here. We'll use Dimension Shifter. Why not, right? So you can use any hand trap for this test. So we're now at a 43 card deck, and let's see what happened to our numbers. So this might be an example of why it's so important to play 40 cards, or it could disprove that theory. So let's take a look. All right, so we're increasing our population size to 43, and we still have 13 starters. So our success of drawing a starter then goes down 2%. Okay, so we had a 91% chance of drawing at least one hand trap. Let's take a look now when we have 18 hand traps in a 43 card deck. 94.4%. So we've increased our chance of drawing a hand trap by about, let's actually decrease that. We've increased our chance of drawing a hand trap by a little over 3%, and we've decreased our chance of drawing a starter by about 2%. So it is an overall net positive of consistency if your main goal is drawing multiple hand traps. If we're in a very combo heavy format, this might be beneficial to understand. But if you want to maximize on your chance of a starter, then you want to play exactly 40. The key here is finding the point of diminishing returns where you've gained the most statistical advantage from your build and then stopping there. You can see that in some situations playing more than 40 is correct. I also want to elaborate on what would happen if we were playing Upstart Goblin. So then for this test, we're going to modify the deck by cutting out some cards. And of course, this is just a test. Like, these aren't cards I suggest taking out. And we're going to add 3 Upstart Goblin, right? So this deck is entirely based on drawing a starter and drawing hand traps. So now we are playing a 37 card deck with Desires. So our statistical likelihood is going to be like 34 real cards in our deck, because Desires simply draws more. Of course, the statistics are not going to be perfect with Desires because it draws 2 cards, but this is a more conservative estimate, so I feel comfortable using it for our calculations. So we do see that this current iteration of the deck has 15 hand traps. So we're playing basically a 34 card deck with 15 hand traps. We now have a 96% chance of drawing it in comparison to, like, let's say a 37 card deck with the Desires. So we've only gained about like 1%. That's like 94 going up to about 96. So we've gained a 2% chance of drawing a hand trap by playing Upstart Goblin. Of course, this is not perfect math because Upstart Goblin does not add the card to your hand turn 1, and so you're not actually getting the residual value off of this. I'm just doing this for statistic purposes. I guess it'll be more relevant when we look at starters, in which case we have 13 of them. So if we have 13 starters, we have a 92.6% chance versus having a 37 card deck, which would be a 90% chance. So we've gained like a 2.6% chance of drawing a starter with Upstart Goblin, which is rather significant, honestly. Over a course of 7 or 8 games, this is definitely going to come up at least once where you have drawn a starter that you wouldn't have otherwise. So you just have to determine what's the point of diminishing returns, right? Like, what did we take out to add these Upstart Goblins? Is it worth a 2% increase in consistency when this could have been like another power card? In my mind, if your consistency is over 85%, you're pretty good. Like, you don't really need to push for that 90% or that 95% consistency, because at that point you're making other concessions in your deck building, and it really is a point of diminishing returns. Let's say you were adding, well, you actually use another example here. So this is my Alistair deck, and it's not using terraforming. We only have 5 ways of drawing Alistair, and that's pretty low. So let's plug it into the calculator. How likely am I actually going to draw Alistair? Right? So let me pull up the calculator here. If I ran this calculation, we only have a 50% chance of drawing Alistair. But if I was to add a terraforming to this deck, so 1 additional copy, that 50% goes all the way up to 57%. You see, it's much different when you're at the lower quantities versus the higher quantities, whereas adding 3 copies of terraforming only increased my consistency of drawing a Zodiac by like 2 or 3%. Adding in just the 1 terraforming increased my chance of drawing Alistair by 7%. So you have to find that sweet spot where you're getting the statistical benefit of playing these cards versus the downside of trying to overcommit to one part of your strategy. So then what is the correct amount of hand traps and starters and bricks to play? Well, I did find this chart, which does break down kind of some of the like choke points. So you can see here where the diminishing returns start to kick in. Around 5-6%, you start losing out on significant statistical advantage from adding more copies of a card. I would say between 8, 9, 10, 11, 12, 13, these are all pretty good, but after like, 12, you're only gaining like 2.5% advantage for adding additional copies. It's really starting to hurt. So you're going to want to probably play between like 9, 10 starters. So that way you have that 75% chance of drawing at least 1. Hand traps can go up to like, 12 hand traps being at 85% chance. These are going to give you really good diverse hands. So that way you're able to, see a wide range of cards in your hand, and you're not just going to get bogged down. If you're only playing 6 starters in your deck and then you're playing like 15 hand traps, well, you're not going to play the game. Your opponent might not play the game either, but neither are you. So it's important to use this. I'm going to let you guys make your own decisions about which statistics you choose, but thank you for watching this video. If you did have any more insight about how to use math on Yu-Gi-Oh, please feel free to drop your wisdom in the comment section. I would love to hear from you guys, and I really appreciate you taking the time to watch this video. If you like this kind of content, let me know what other kind of videos you want to see, and I will work on making those. So thank you so much for watching, and I hope you all have a great rest of your day. Take care.